Hey y'all, I'm gonna do a little something different today. What's up, Peanut? Yeah, ready to code. Yeah, all right, I got some viewers tonight. I love it. Thanks for joining me on this. Gonna do a little bit of some coding. It's gonna be some C#, and I'm gonna throw a bunch of like wacky things at solving this that are way overcomplicating this. But I just kind of want to have fun with this. This is one of the things I love to do, is take a really simple, like straightforward solution to an easy problem, and then just like, okay, but what can I do to way over engineer this? And that's what I'm going to do with this. So it's going to be a little bit of fun. All right, I'm going to jump right into it. Thanks for hanging out with me. Let's see. Let's grab, we want to do the live scene. So let me transition that over here. Let's start off with taking a quick look here. You guys like the music? A little nice royalty-free music in the background. It's nice. So this is CodeWars. I don't know if you are at all familiar with CodeWars. It's a great tool to go practice and train yourself on just simple, like little katas, little things, easy. Sometimes they're easy, sometimes they get progressively more difficult to try to solve these challenges. And I was just kind of tinkering around and doing some of these CodeWars things, and I thought, well, I'll give this one a try. This one is the area or perimeter. Very simple, very basic one. I've seen this one as just like even an interview type of question you might get. And this is area or perimeter. So the basic thing is you're gonna get, and actually let's take a look at the test here to see what the tests say. I'll expand this out. So it's an NUnit test framework here that's being used to run just one single test that checks to see if we run the area or perimeter method and pass it 2 parameters of 4 and 4, then we should get 16. If we pass it 2 parameters that say 6 and 10, then we should get 32. Now that may sound a little weird to you, but what it is saying, well, if this is a square, give me the area of the square. So multiply 4 times 4 to get 16. But if this is a rectangle, then I want to get the diameter of the rectangle. So that would be, with 6 and 10, that leads 16, but you have to double that because you're getting one side and then the other side. So add those 2 values up, and then you have to double that in order to get all 4 sides, right? Because that's how we get the diameter or perimeter of, perimeter of a rectangle. You could also do it with a square, obviously, too. But you have to make a decision here, right? It's pretty simple. Like, you'd think maybe just a little if-else statement, right? So let's actually tackle this here. I'll read over the instructions here just so you can see them. You are given the length and width of a 4-sided polygon. The polygon can either be a rectangle or a square. If it's a square, return its area. If it's a rectangle, return its perimeter, right? So very simple. Give it 2 values, 6, 10, return 12, 32. 3 and 3 would be 9 because that would be an area. That's a square on the bottom, rectangle on top. Okay, hopefully we're all set on what the challenge is, what the kata is. Digging the tune. Thanks, Renee. Okay, so our tests here, looking at them, it's just running those 2 things. And of course, if we test it right now, we're gonna get an error, right? We're just gonna get blah, no can do. Now, I'll tell you that one of the downsides about, one of the down things about CodeWars, I wish that they had this. I kind of understand why they don't, but there's no IntelliSense here. So if I start to go in here and start to type out my solution to things, I'm just going to get absolutely nothing, okay? So no IntelliSense here at all. So if I just start typing out, let's see, what do we think would be the simple solution here? Like if L equals W, then we want to return L times W, right? So that way, check to see if it's a square, because if both the values are equal, then that means it's a square. So we're gonna try to figure out the area, which is just simply length times width. Okay, and that would be our return. Now you might be tempted to do something like this if you want to be, a little bit more rigid about your syntax here to make it real clear. You might do something like this, and then have like an else statement here, and do return L plus W, and then we gotta. Now, what would be the problem? I'll just do this real quick. Real quickly, what do you see as the problem with doing it this way? I said, let's move this curly brace down here. I'll line them up a little bit. I really don't like how it's done right there. Nice, thank you so much, Miles. That's awesome. Yeah, so Miles says, thank you for kickstarting my Axis Journey Legendary Series. Oh, you're welcome. Miles, I'm glad that I was able to help you out. Axis it's near and dear to my heart. That series was, gosh, so long ago. That was like 10 years ago that I started doing that series. It's hard to believe. I don't really do much Axis anymore. I don't really get my hands on it too much. Now I'm in like Java, a little bit of .NET world, AWS, more agile and DevOps type stuff. Agile because a lot of agile training with teams and stuff. So that's probably why you've been seeing a little bit more of the agile and like management leadership type of stuff on my channel. So hopefully that's helpful. But all right, let's move on to what we got here with the order of operations. Now PEMDAs, I think the European countries had a different way that they did this, but this actually, I think, is still going to work. No, it's not, because it's going to do the order of operations, which is the multiple first, and we don't want to do the multiple first, right? We don't want to do the width times 2 plus the length, because then if I just run this, it's going to error out on having, the wrong order of operations. So in order to get that, I need the length and the width to be evaluated first. So we wrap this simply up in parentheses to indicate that we want parentheses to be run first. And if we test this, voila, we should be getting a passing result. Okay, we could shorten this up. We could do a couple of different things to maybe make the syntax here a little cleaner. And you saw me doing one of those things. This is a very typical early return type of syntax where we don't really need the if, or we don't really need the else statement if we're just going to return immediately. So we could just drop the else altogether, because we're going to say if this, then return the length times width. But if it's not, then we're going to do this other thing and return that, right? So we don't even need the else statement at all. We could just say if this, then return that, right? And if we test this again, we're going to see it passes again. Awesome. Okay. Steve, I thought you said this was going to get really complicated. Okay. Well, I'm going to dig a little deeper into some syntax here to make this even easier. And I'm going to use the ternary operator. So maybe some of you are familiar with the ternary operator. Effectively, what the ternary operator is a shorthand for an if statement. So what I can do is I can move the return to up here, and I'm going to, since both of, let me backtrack here. Since both of these expressions are essentially, or the return results are dependent upon a single expression being either true or false, what I can do is I can say the same thing as if else, but rather than using the if else statement, I use first evaluate the expression, and then if it's true, do this, then the other thing through the ternary operator. So I'm just going to say return something based upon this expression of L equals W. And then the ternary operator, it's sometimes called the Elvis operator. I guess it's supposed to look like Elvis, maybe. I don't know why they call it that, but it's called the ternary operator. And then what you do is, if it's true, then you want to return length times width. And then if it's not, then we want to return length plus width times 2, right? So something simple like that. But I don't need the return statements at all because I already have the return right here, right? This return is going to return the result of this expression, right? So based upon the length equaling the width, if that's true, then I want you to return length times width. If it's false, then I want you to do the L plus W and then multiply that by 2, okay? Pretty simple, pretty straightforward. If I run this, because it's just an if statement, right? That's all this is. It's still it's a simple if-else statement. It's just done in a slightly different syntax to make it shorter, right? Like this is way simpler, okay? But that's a little extra, like that's a little deeper knowledge. That's not what I've come here to show you. This is simple compared to what I'm about to show you. We're gonna get into some really expressive ways of solving this. Now, I took this code, and like I was saying earlier, there's no IntelliSense with CodeWars, which kind of bums me out. So I went ahead and brought it over here into a .NET 7. This is I think it's .NET 7. It might be a .NET 8. I did get the latest .NET version. And let me see here. Let's trash this. Let's see if I can remember my .NET version. Oops. There we go. Okay, so I am running 8, which just got released like 2 days ago. So this is brand new version of .NET. So some of this might look a little funky, such as like global usings here, which is where you can bring in using statements. And I just realized that that's there. Therefore, I don't actually need even this NUnit framework because it's already in my global usings. So the global usings, this is a new functionality with .NET. They brought in this global usings class, or I shouldn't say class. It is a CS document, but it's not a class. It's a CS file that allows you to say that across all of the classes, we want to allow, or just kind of globally have this this namespace available to all of the classes within this project. So this NUnit framework, this using statement for NUnit framework, I actually don't even need it here in my test, my unit test. And I think I could probably do the same thing for system, although I think system is just redundant anyway. I don't think I need to have system anyway. Just delete all that. Okay. The other thing that they did was they added this syntax where you can put the namespace. You could just name the namespace at the top here and use the semicolon terminator, and then everything within this document is now going to be in that namespace. That's different than how it used to be, where you would have to use the open curly braces and then close it off at the end here with the closing curly braces. So they've gotten rid of some of that syntax, which is nice, not a huge deal, but I think it does make it a little cleaner. Okay, let's just auto format that. Okay, so now this way I get some IntelliSense, because I like to have the IntelliSense. I also have Copilot installed, so we might see some funky things pop up on my IntelliSense. But here's what we're gonna do. Right now I can't even run the test, because if I do, it's just gonna error out. It's just going to tell me because the area or perimeter doesn't actually return, not all code paths return a value, right? So there's nothing being returned here at this time. Okay, I don't really care about the output. So, okay, my tests aren't going to pass, which just means if we're doing TDD, we're in the red phase. This isn't really proper TDD, but that's okay. We're starting off with tests that fail first. Okay, what we want to do here is I want to allow for the first thing that I identify whenever I see like an if else or any sequence of like a switches or ifs or else, what you ultimately is kind of more, we're gonna follow open close principle, which basically means open for extension but close for modification. That means that if I had a series of if else statements like we were doing, it's kind of a closed system. I don't have any other shapes that I can accept, right? I I can't take two values and do something different with those values. I'm either stuck with a square or a rectangle, no triangles, no circles, no anything like that, right? So I'm limited to just those two options. And I would have to completely rewrite my code to accept a different situation. I'd have to add a switch, I'd have to change my if statement to a switch case statement, and then add a bunch of switch cases. But then that means I'm still kind of closed scope on that, because every time that I introduce a new rule to this sequence, then I have to basically go into the switch statement and do it. Now what I'm gonna do here is fudging that a little bit and saying, let's try to adhere or do more open closed type things. And one of my favorite patterns to fix or solve this kind of switch or if else situation is to use something called the strategy pattern. And I have a bit of a different take on the way that I'm going to do this. I think you'll get a good, this is going to be kind of fun here. Okay, enough talking, Steve. Let's see the code. All right, so the first thing we're going to do is I want to create a set of rules, okay, that I want to pass the values of length and width into these rules, and then have the rules tell me whether or not they match the situation, and if it matches the thing, then return that result. Okay, let me start that again. I want to get the rule, I want to create a set of rules that I'm going to pass the length and width to, and if the length and width match that rule, then I'm going to return the result from the rule. Okay? Now I've done this before. I think I did this with like interfaces and classes, which is one way to do it. In this case, what I'm going to do is I'm going to create an array of functions to do that. An array of functions? Holy crap, Steve. This isn't JavaScript. No, this is C#. We're going to create an array of functions. So how do we do that? Well, luckily for us, there is, for some of you who may watch my C# Advanced series, I kind of showed you some of this stuff on Func of T. So what am I going to do? Okay, well, first of all, I need to create an array of these functions. So a func of T. Okay, now it's not actually T. We're not going to put in T. T represents the type that you want for functions. Now the func of T, you pass in effectively the parameters and then the return result. So if I just said func of int, this would mean my function is going to return an integer. And whatever the last generic value is that I pass in as the last generic parameter, type parameter, is going to be the type that's returned. So if I said int, 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 then what I'm going to be saying is take in a int parameter and another int parameter and return an int. Okay, that's how I'm defining a function. And I can call this function something like area function. Okay, so I could do something like that. Now to create this function, I'm going to just simply do new func, and now I'm actually going to define it. But I have to use the same int when I'm defining it. By the way, I could have probably have just done this. This would have been simpler. Var, because it'll automatically translate this new function that I'm writing. It'll automatically derive the type at compile time and decide that it's a func. So it's a little simpler syntax, right? Okay, so we're gonna func. And what this is simply gonna do then is, so this is gonna be func. Actually, I don't even need to do the func. How do I want to do this? You know what? No, I'm gonna do it this way, because it is gonna be better syntax this way without the var. I'm gonna do func int. Now you'll see why I'm saying to do this, because the syntax that I have to use in order to write this is just going to be a simple lambda expression, which is just simply using the I and j and goes to, okay, so this is a lambda expression. So we're writing out a lambda expression, which is just basically a shortened version of how you would define a function, right? So we're taking in two parameters. So the first parameter is I, the second parameter is j. So we're defining this area function, okay? It's gonna take in two integers, it's gonna return an integer, and so I have to define here at first what are the two parameters that I'm taking in, and what are their names? What are the variable names? These would be like, this is an integer of I, and this is an integer of j, okay? So I'm taking in those first two values that I've typed in my func, and the return needs to be some sort of integer, okay? Now this is gonna be, if it's an area function, then it's gonna be I times j, right? So if we know that what we're gonna do is return, why don't you like me? Why don't you like me? What are you unhappy about? This should be, oh, maybe it's the ints. No, I think I should be able to type parameter my ints. Uh-oh. This is what happens when you live code. Stuff like this happens. Oops. The name area function does not exist in the current context. Func of int. Using generic type requires one type argument. This should absolutely work. I don't know. It encapsulates a method that has no parameters. Yeah, that's what this is. Well, why are you red squiggly? Oh, using the generic type function requires one type argument. I have 3. Oh, missing a comma. There we go. Oh gosh, missing commas. There we go. Okay, but we figured it out. Okay, so taking the three generic type parameters, area function, we've defined our area function. Let's define another function here. That's gonna be our perimeter function. So this is gonna be func, and it's gonna take in the same, it needs to take in the same ones, int, and int. And this is gonna be our perimeter function. And again, we're gonna do I and j. And we'll just say this time, it's gonna be I plus j, right? It's that rule that we were talking about before, times 2. Okay. All right. This all is starting to, hopefully maybe some of this is starting to click a little bit here. We've got two functions defined. Okay, so this is the crazy thing about, I mean, this was introduced quite a while ago. This func of T has been in the .NET and C# for quite a while. But effectively, I'm defining a function as a variable, okay, as some sort of variable. That's what I'm defining. So I can now pass this around. I can say, go execute this function. I can just pass that function to some other function for it to execute the function, right? That's kind of weird. Here's the function I want you to run. But see, that's where it matches into the open close principle, because now that function that is gonna call, that I'm passing this function. So I have function A that's gonna receive function B as a parameter, and function A is going to call then the function that it's been passed to go do its work. So that way you can pass it whatever function, you can pass function A, whatever function you want, and it'll execute it, right? That's what helps make this open closed, is because it allows me to just kind of randomly define whatever the function is going to be. Okay, great, Steve. But this isn't all we're gonna need to do, because how do I know that, well, first of all, yeah, so how do I know that that I'm supposed to do either area function or perimeter function, right? That's a good question. So what I actually need to do is I need to come up with some way of evaluating whether or not we should do area function or perimeter function. And here's the thing about rules. When you're doing a rule like this, you want it to be kind of self-contained. You don't want to have like, so, okay, let me backtrack here a little bit. I'm kind of going off the rails here. Let's do a simple little thing. If L is equal to W, then we're going to, this is how this works. We're going to call area, oh, actually I need to do this below after I've defined those functions. So I've defined my two functions that I could execute. So if L does equal W, then we're going to go ahead and return, well, actually, let's do this. We know that we're going to need to execute area function, and we're going to need to pass it in the two values of L and W, right? Okay, that seems pretty simple, right? That's all we're going to need to do. We're just going to need to return the area function. So we'll do return area function, and then else return perimeter function. Right? Okay, does this pass? Maybe. Wait, why is it saying not all code paths return a value? They look like they return a value. Let's try it. Yeah, we pass. I don't know why I was saying, I don't know, that's weird. It's absolutely all pass return. So this is kind of interesting, right? We have two different functions that we could call that we've defined effectively inside of our function. It's kind of like creating a function inside of a function that we're going to figure out which one of those functions to call and do the calculation on. That's kind of handy, right? Like that's kind of a neat little thing that we can do. But we still got this if and return else statement thing kind of going on here, and it feels a little janky to me. So I'm gonna do something really goofy. So I'm basically defining two different rules here. I've got one that's the area function, one that's perimeter function. What I'm gonna do though is I want this function to return for me not just the value, but I want it to be able to make this determination, if and else, because right now they don't actually constitute any sort of rule. They're not rules, they're just functions that do the calculation. What I want is to actually pass in a function or call the function, and if it returns true, then give me the result, right? So do this expression or check to see if length and width are equal to each other. If so, then do it. But I want the rule itself. I want the function itself to make that determination and return for me the result. Okay. So how does that work? Well, luckily they've introduced in .NET, and I forget which version of .NET this is. It was about, I think it was 6.0. No, not 6.0. C#7. I believe is when they introduced the idea of tuples. And what's a tuple, you may be asking? Well, you can go search it out for yourself if you want, but effectively, a tuple is just a way of grouping results together as one result. So two values being returned as one result without having to specify it as a new data type, okay? So I can return multiple. I can return up to like a bunch of values. Like if you look at, as a matter of fact, maybe here's what I'll do. I'll pull up the, let's go to tuple, C# tuples. And tuple class. All right. Now if we look at tuples here, effectively we can do it this way. This is one way to create a tuple, which is just called tuple.create, and you just pass it in the values that you want to have inside of the tuple. And it's kind of like a way of declaring a read-only data type, right? Like you can't, once you create this tuple, that's it. It's got the values in it, and that's all there are, okay? So I can create this object called a tuple and just pass it in the values. Like here they have 2, 3, 5, 7, 11, 13, 17, 19, or whatever values that I want. And I can even print them out, as you can see here, just by simply getting each one of these values out of the tuple. So the item 1 is the first item in a tuple. Item 2 is the second item in a tuple. Item 3 is the third item, etc., etc. So if I go and create a tuple here, you can see they've created one called primes. Okay, now primes is a tuple, and it has effectively all these values grouped together. And if you want to access each one of them, you just simply call item 1, item 2, item 3, etc. Okay, so I can group things together. Now, and that's not the only way you can create a tuple. You can also use this syntax, which should look a little familiar, right? This is using type parameters to say, I want to go create a tuple. The first value is going to be a string. The second value is going to be an integer, etc. So you can see that here's a tuple for New York, which contains these values of, looks like probably the population, I think, maybe of New York over the course of like each year, perhaps, is what I'm guessing. Yeah, and then so in the year 2000, it was that many, right? This would be the year 2000. So that's kind of how they're framing this as a tuple. But the key thing that I want you to pull away from here is that a tuple is like a way of just kind of grouping values together so that you don't have to define some sort of class or record or any specific definition of a value. You can just say, here's a tuple, it's got values, use it. It's a very convenient way of just like passing values back and forth, because functions are limited to only being allowing you to return a single object, right? So when you return a value from a function, you can only return one. Now you could make it a list, you could make it an array, right? There's other ways you could do it. You could make it a class and then have different properties on that class. You could certainly do that, but a tuple is just like a real fast, easy, quick way to do that that doesn't make it too complicated. That's what we're going to do with our rule set. So I'm going to go back into my code here. And now I'm going to say that not only do I want, so the return result is not going to be this int, right? This is the third type parameter of the function, of func of t. The third type parameter is the return type. Now what I'm saying I want to do is I don't want it to be an int, I want it to be a tuple. So I'm going to bring in tuple. And the tuple, it's gonna have two values. The first one is gonna be, is this true or false? Does this rule match? And the second is gonna be the return result of the expression, of the value, right? If I multiply I times j, it's gonna be the value, which is going to be the int. So I wanna do bool and int as my return type. Okay, so I've got an int that's coming into this func of t, a second int is coming in as the second parameter of the func of t, and I'm returning a tuple with a bool and an int. That's my return type. I told you this was going to be complicated. Hopefully you're learning something. This is a little bit of like brain bending stuff here, because we're doing functional programming rather than basic OOP or procedural function development here. Okay, so we're going to take I times I. We know that that's going to be the second part of what we want to return, right? Is this value I times j. That's going to be the area. That's supposed to be this int that gets returned as part of the tuple, the second value. I need to also return whether or not I is equal to j. Okay, so basically it's both this expression of I equals j, which would be true in this case, and I times j would be the result, the value of the of if I and j were equal. So how do I turn this into a tuple? Well, luckily for us, there's a very simple way that you can create a tuple out of values like this. I showed you we can do the new tuple here where we're defining the type like this, tuple this way. But there's actually a very, very simple syntax. I'm so glad they added this to the C# language. You just simply put parentheses around it. And it's comma separated. So now we have a tuple. Okay. Why don't you like it? Cannot replace true the tuple zoom. Wait, what? Why not? Oh, no, that's right. I can't do it with this. I do have to define it as a new tuple. I'm sorry. I goofed up. Now this does need to be new tuple. I forgot that's the deconstructor that you can do. That might come into play a little bit later, but we'll do tuple, new tuple this way. And I do have to define, it's going to be a bool and int. Right, there we go. Now the compiler's happy because I'm defining my tuple. It's true. I do need to do the type definition. I don't think it could explicitly, I don't think it could implicit convert that. So, okay. So new tuple, bool int. What we've done here is we're saying, and this is really way complicated, right? Like I'm taking now my I'm taking my function that's called area function, takes in the parameters of I and j, and it's going to return a tuple. The first value of the tuple is the true or false, yes, I equals j, and then it's also going to do the calculation of I times j and return both of those things as one single value, that it's both true or false and the I times j. We're gonna do the same thing with the second one here. I'm gonna say tuple, bool, int. I already have int there. Don't need that. Okay. So now I need for my perimeter function, new tuple. It is first going to be a bool. The second value is going to be an int. And we're gonna do, now, okay, here's where things get a little bit tricky. You gotta think about this. You gotta think this through. If I did I equals j, again, that's not really gonna work. That's not when I want to return this I plus j. I want it when I does not equal j. Oops, put the space in the wrong place. So I want to do that. Let's get the syntax where it's happy. There we go. Okay, so this is weird. This is weird. We got a new tuple. The first value of the tuple is going to be a true or false statement about whether or not I does not equal j. And if it does not equal j, then that means it's going to return true. And if that's the case, we wanted to return I plus j times 2 to give us the perimeter, right? So now what I can do is, instead of doing L equals W in this if statement, I can simply just ask to return. So if we do something like this, it's not great syntax. It's not better, honestly. This is not going to be better. It's still going to be an if statement, and we're going to check area function. And we're going to want to see if we pass area function L and W, we want to check to see if item 1 is true. If it is, then we want to return area function LW item 2. We want to return the second item of the tuple if the first item in the tuple is true, right? And then if perimeter function, we're going to do the same thing. Pass in L and W, and if item 1 is true, then we're going to return perimeter function LW dot item 2. Okay? Just, I think it's probably good to take a moment to pause here and look at what we're doing, because you have to remember, func of t means we're actually defining a real, actual function. This is a real deal function. It's a first-class citizen in C# now, right? I'm not defining a function like I typically would over here, you know, down here, like saying public static. Well, I mean, like, yeah, it's area perimeter, right? The area or perimeter is a function, obviously, right? I'm not defining it that way. I'm defining it this way. And just as kind of maybe a quick comparison of what this function looks like, if I was to do public static, now this would be tuple, bool, int, right? The return type is a tuple. And then the parameters that I'd need would be the int L and int W. And then this would be, so what does this need to return? Well, it needs to return a tuple. So return a new tuple that's going to be of type bool and int, right? Like that's what we know we're going to have to return from this function. I'm just recreating this function right here. This one that's the area function. I'm just recreating it down here. It's taking in an int and it's returning a tuple. And that tuple is bool and int. And the way we're checking this, so the new tuple is, so return L. Oh, nope, we don't want to do that. We want to, oh yeah, so it would be L equals W is the first, and the second is L times W, right? So that's effectively all that we're doing is we're just saying return a new tuple with this expression. Oh, I forgot to add, this is area function. I'll just call it area function 2. I think that's why it's choking right now. Oh, no. I put that in the wrong spot. It's got to be here. There we go. Okay. Got to make the compiler happy. Otherwise, it doesn't like these. So I just want to show you this area function here is the same as this area function here. It's the exact same thing. They're the same. They're exactly the same expressions, just written differently, right? So what I want, and this, so if I actually replace this, I could just comment this out and say, instead of area function, I do area function 2, and notice it's satisfied, right? It's the same, it's kind of cool, right? Like this is cool. You can define a function as a data type effectively, right? That's really great. Okay, enough crowing on about that. What we're gonna do is, let's go back to, I'm gonna delete this. Well, actually, let's comment it out, because maybe some of you want to see that and think, and just as a reminder of what this is actually doing. Okay, so, and I need to return this to area function instead of area function 2. All right. So now the challenge here is, or what we're seeing is, we've got still kind of an if statement, and not all situations, well, I mean, technically every route would be returning true. The compiler's not particularly happy, but I think we're going to be passing all our tests. So a .NET test. It should be passing our tests, I think. Let's check. Oh, no, it didn't like it. Not all code pass return a value. And that's because I have an if statement. Okay, so it's not happy. The compiler is not happy because I've got the potential for some other thing to happen. Because if item 1 on this perimeter function is not true, then theoretically, I might not return a result. Now we know, of course, that I is equal to J or I is not equal to J. One of those two things has got to be true. Like there's no other way that it could not be true. One of those two things is true. But the compiler doesn't understand that right now. Okay, I told you I was going to complicate this. So what we have to do now is we've got to, instead of doing this, let's do a loop over these to return a result. How do we create a loop to return over the result? Well, what I'm going to do is I'm going to take these two functions and I'm going to put them together into an array so that I can loop over the array. So instead of separately defined functions like this, I'm going to create array of these functions. Since they both have the same signature, right? They both take an int, they both return a tuple, and the tuple is both a bool and an int. So I'm gonna say func of int tuple, and again our tuple is returning is comprised of a bool and an int. Okay, and it's an array, so I need the open close straight brackets, right? Now I'm going to call these rule expressions. This is my list of rules. These are my rules. And I'm going to set them to a new, again, I'm going to do func, yeah, blah, 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 array. Open curly brace. And I'm going to put the close curly brace down at the bottom of these two functions. Let's give a little space here. And now what I can do is I don't need to name them anymore. I can just delete. I could just delete the type definition altogether here. Because since they're an array of the same data type, this should work. Oh, and I've got it doesn't like it because I have semicolon. I need to change that to a comma. And this doesn't need to exist here as a semicolon. So now I have an array defined of two, of two of the same functions, right? They're basically defined the same way. So I can create an array of the same data type, which is a function that matches the same signature, right? That's all that's happening here is I have two functions with the same exact signature, so therefore I can put them both in an array since they match the same signature. Now that I've done that, and by the way, notice it's saying, well, this is kind of redundant, Steve. You don't really need that. So I could delete that, or I could also change this to a var. Whichever one you want to do. Yeah, let's go ahead and just delete this where it... Yeah. All right, so there you go. So now I've got an array of functions defined. Now I need to loop over them. How am I going to loop over them? Well, I could do like a while statement or a for each if I wanted to, because this is just an array. This is an array, so I could do a for each. Let's just call them, well, so now each one of the functions, I'm just going to call it var so that I don't have to type out the whole data, the whole tuple bool thing. But it's going to say for each var expression, I'm just going to call it ex in rule expressions, right? Then I'm going to call the ex and pass in LW. Right? So now I'm effectively looping over those functions. And then I could say if the first item, I know I'm doing another if expression. I'll fix that in a bit. But if ex.item1 is true, then return ex LW item 2. And now I can delete all of this. And that's now a much shorter version of this. Let's see if the compiler's happy. I'm not sure if the compiler will be happy. Yeah, it doesn't like that. So we'll do, and there's a reason why, and that's because there's still the potential that this doesn't return the right thing. I'm going to make the compiler happy so that it runs the tests by saying return null. Okay, this should make the compiler, oh wait, no, return 0. Because null is not going to be possible here. There we go. No, I think it's going to be fine. Because I'm trying to return an int, and obviously null is not a valid expression of int. So there we go. Okay, we passed our tests. Right? We passed our tests. It's working. That for each, if we check item 1, which is the bool that says this rule is the correct valid rule, then return the result of this expression of I times j if it's if I is equal to j, right? So I'm using my facial expressions instead of showing you on the screen. But we're saying that if this rule is true, where this I and this j is equal, then return, or then take the second item in the tuple, which is I times j, the result of I times j, return that value as our return for this area or perimeter method. Okay? Now, if you recall again, when I did my kind of more advanced C# series, I took this and did something, or I did something similar with the for each, and I did something a little different. I'm gonna do it again. I'm gonna get rid of this for each. I don't like the fact that I'm returning 0 here. I'm gonna do something totally different. I'm gonna use Linq to do some of this logic for me. So rather than doing this for each like this, I'm going to take the rule expressions, and I'm going to find the first one. I only need to find the first one of the rules that matches. So I'm going to do a first or default. So find the first rule that matches or return the default value. Okay, which means effectively, remember how I had to do this return 0 down here? The default will basically return 0 for me if it doesn't match a rule. So it's doing that for me. So the first or default will say, find the first one that matches our criteria. If it doesn't match the criteria, then return the default value, which will be 0. So it's doing all that logic for me. Thank you very much, Microsoft. Okay, so first or default. Now what I need to do is I need to inspect each rule, execute the rule, and see if item 1 is true. Okay? So I'm going to do, let's just call it rule. Now, first or default takes a lambda expression. We've been seeing those, right? This right here is a lambda expression, right? That whole line there is a lambda expression. This is the same thing. Rule is a parameter that this function takes. So rule is going to be the name of this function, right? It's giving this function the first time through. As we're iterating, we're doing basically a loop over these rule expressions. It's looping over them. It's checking one at a time. And the first one comes up, right? This one that I've defined here, that's I and j, that's doing it's basically our area one, right? It says if I is equal to j, then do the multiplication, right? That's the first one it's going to evaluate. And this then becomes named rule. So this function that's doing the evaluation of I equals j is going to be named temporarily the function name of rule. Okay? Now all I have to do then is go ahead and execute rule and pass in the two values, which are L and W. Okay? Now first or default needs to have a true value to it. So I think you can see if I hover the mouse over here, what it needs to know is returns the first element or sequence or default value if the sequence contains no elements, if the source is empty, otherwise the first element in the source. So what I need to do is I need to give it a function that will return true or false. And if it's true, the first time that it goes through this loop, once it hits one that is true, it will return just that one. But what it returns is a function. It's not returning a value yet, it's returning a function. It's going through the rules expression, find the first rule expression that returns a true value, and if it's true, then return that thing, that object from the rule expression array, which means it's returning a function. So I'm calling first or default, passing it in a function in the term of a lambda, that lambda expression. If that lambda expression returns true, then it will return that rule to me. And that rule is another function. Oh my God, this is crazy. Steve, you're way complicating this. All this was an if-else statement. You saw it yourself. It was one line of code. It was one line of code. Look at what we've got now. This is crazy. This is insane. It's going to get even more insane. Okay. All right. Rule LW. Now, what do we know that so we know that on this rule method, right? And again, we're looking the first time through, just imagine that this is the function that's being checked. This is the function that's being executed here and passed in a length and a width, which are now called I and j. And it's evaluating the length and the width to see if it's true. If it is, then it returns true. If it's not, then it returns false. Our first or default wants to know whether or not that value, is true. So which value? Well, we're returning a tuple on this function, right? This is a tuple that it's returning, right? So we want the first item in the tuple of this function. That's the one that we're going to get to see whether or not this is a matching rule. Okay? So I'm just going to need when I execute rule is going to return a tuple. And the way I access the first element of the tuple is to use .item1. That's going to tell me whether or not it's true or false. Okay? But remember, and here's the crazy thing, first or default returns that function, right? It returns this function. So if it finds that it's true, return it, okay? So if I'm returning a function from this first or default call, right? First or default is going to return the function. What do we do with the function? Well, we execute it. We invoke it. So there is on a func of t, there is the .invoke method on it, where when we do this, we pass it in the two values. So we can do L and W. Now, when we invoke it, again, we're invoking this expression. Okay, we're invoking this expression. Now, I don't want the item 1 this time. Now I want the item 2 from this. So I'm going to return .item2. Okay, but I actually need to return this. It's not, I gotta actually do the return because I'm returning item 2 from out of this whole thing, right? I'm trying to satisfy this public static int of area or perimeter method and giving it back an int. Okay, so I want to get the item 2 from the invoked function. Let's run this. Passed! Holy crap. We've passed. Now there is a simpler way that you can do the invoke, by the way. You just don't even need the .invoke. You could just do the open close curly braces because effectively, again, it's sort of like, and just to kind of break this down, if I were to just define this as a variable of confirmed rule. Okay, so first or default is going to return for me the first rule expression, the first method, the first func of t that returns true on our expression of when item 1 is true. It's going to return whichever the first function is, first func of t that has matched to true. It's going to return that and then set that function to this confirmed rule variable. Now what I could do is just think of this confirmed rule as a method or a function, right? So I can call it confirmed rule. I could just call it and I can pass in the L and the W, right? Now, so it's just a regular function. And I would, of course, remember, again, since I'm returning a tuple from confirmed rule, I would want to get that item 2, which is the actual value of the confirmed rule, and I need to return it so that it satisfies now the area or perimeter method. Okay, right? And I'll just prove this to you again. The .NET test is going to run, it's going to pass everything, right? So this is just a method called confirmed rule, but I don't even need to do this. I don't need to assign it to a variable one time just to go execute it. I can just actually execute it, which is just putting those same, or just calling it, right? This open and closed parentheses around it is just calling the method that gets returned back. So I can pass in L and W to it. And again, I want to get the item 2 from that call, and I'm just returning that value. okay? And once again, we're gonna pass. How crazy is that, right? Okay, so just to prove all this, I'm gonna go back to the original source of the question. I'm gonna go take my solution here, just this bit of code. And I'm gonna go to my, let's see, where did it go? I think it's right behind it. Yeah, here we go. Okay, so remember, this is our simple little solution that we had here. It was one freaking line. It was one line. I just love that was one line. And now we're gonna paste in our solution here. I'm gonna need to bring in, I think, a couple of usings though. I think because I'm using Linq here. So I need to bring in Linq. System.Linq. And if we test this, I'm missing a namespace. What am I missing? Tuple. Oh, I'm missing system. It doesn't automatically import system. Look at that. We made our very, very simple request much more complicated than it needs to be. And it took us an hour to do it. All right, I'm gonna go ahead and submit this as an attempt, because why not? I could comment it, but I'm just gonna, I have two, why do I have two semicolons there? That's weird. All right. So I just want to recap here, taking a look at the code, just to kind of go through it piece by piece to break it down for anybody who wants like the TLDR of this. Right? I've got an array of functions here defined. The functions, this is using the func of t data type in C#. The first two type parameters are the parameters of the function. The third data type is the return type of the function. So for any function, you need the parameters you're going to take in and the return type, right? The input type, the parameter types, and the return types. The first two type parameters of a func of t are the parameters that it takes in, and the last data type is the return type, the type that will be returned from the function. In this case, we are returning a tuple, okay? And a tuple is a data type that you can basically have a bunch of different values that are just kind of collectively put together without any real, without having to define a class or a record or a struct or anything like that. Right? You just have to say, this is a tuple, I'm gonna throw some data at you. It's up to the consumer to figure out how to deal with the data, right? It's up to the consumer to figure it out. I don't have any specific format to this. It's just gonna work according to that. So according to the consumer, they're gonna have to figure it out. So now I've got a tuple. The return type is going to be a tuple. The tuple is going to have two values in it. The first one is going to be whether or not the rule is the rule that should be executed. Either it's true or it's false, right? So and it's returning yes or no. Either this rule matches or it doesn't. The second value of the tuple is going to be the actual value that's returned when we do the mathematics of this. So now I've defined these functions, these func of t's, as an array, which means I can have multiple versions of these. I can define as many functions as I want in this array. I can have as many of these func of t's, as long as they match the signature of int goes in, another int goes in, and the return type is a tuple of bool and int. As long as the function matches that, it can go into this list. And in fact, I can even define a function here. Here, let's do this one. This function or area function 2, right? That matches the signature. It takes in a bool. I'm sorry, it takes in an int and another int and returns a tuple of a bool and an int. So it matches this signature here. So therefore, I could theoretically add the named function here of area function 2 as yet another item in this array of rule expressions. So you can go create, you can name them if you want. You can name your functions elsewhere and then say, yeah, go add that rule into this collection. And yeah, go add that rule to this collection or this array, right? So you can just like take them from wherever and put them into your rule sets, right? This array of rules, and then iterate over them until you find the rule that you want to execute. That's what's great about this. That's why this adheres to open-close principle, because now I can define a function somewhere else, anywhere else in my code base, and just say, hey, go import that function from over there, and I want to use it here. I'm just going to throw it into my array of rules to execute this against. That's pretty cool. Now, in this case, I've went ahead and just defined those functions as lambda expressions, which is great. And the first one, of course, is just going to be, the first one that's going to return true is this one. And we're doing a first or default. Well, I should say the first time. So when we're running the test, let's take a look at our tests again here, which are, yeah, up here. So the first time, 4 and 4 are going to be equal, which means it's going to match this expression of I equals j, which is going to return true, which means I times j is the one that's going to be returned from the first or default method call that checks to see item 1 from the tuple to see if it's true. Once it's true, then it takes the second item out of the tuple, which is I times j, and we return item 2 off of it. But the only reason that happens is because first or default doesn't return item 2, it returns the function itself. It returns this full expression of I and j, tuple, I equals j, blah, 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 right? It returns this function. And so we still have to execute it again in order to go get the value, the second item out of the tuple. I didn't say this was efficient. I didn't say this was correct. This is not great. This is honestly like terrible. I gotta be honest with you. Like, this is terrible. The first solution we had was obviously the right one. Where we just simply do the Elvis operator. We do the ternary operator. That's the correct answer, I think. And there may be some other ones out there. In fact, let's see what other kind of solutions people came up with here. Yeah, there it is. That's the top rated answer, is the one that I gave you at first. But you can see nobody's going to come anywhere close to the complexity as I just showed you. Area or perimeter. Oh, they use the trick. I mean, the same thing is still true. Wait, no. Yeah, the same thing is still true. Wait. Okay, my mind is a little blown there. That's clever. That is clever. That's just understanding that's understanding the math well enough to realize that you can just simply multiply whatever the length times width is, and you can just multiply it by 2, and you still get the same answer, whether it's a square or a rectangle. Wait, no, that doesn't. No, you know what? No, that doesn't make sense. I bet if we gave a different value, it wouldn't work. I bet it just passes the tests. I don't know. I maybe I'll go down below. Anyway, I hope you guys enjoyed this. This is fun. It was a bit of a different thing for me to try. I might do some more of these just to kind of mess around with stuff and show you some cool things. But yeah, no one's going to come anywhere close to the really complicated solution that I put together. Is anyone even? Yeah, no one's going to come up with this. I don't think anybody would for science, F around and find out. They wouldn't do that. All right. Thanks everybody for watching. I hope you had a wonderful time. I hope you learned something from this. Tuples, Func of T, all sorts of zaniness, and looping over them, and Linq query expressions. Oh my gosh, the whole thing has been wacky. All right. Thanks so much, everybody. You have a wonderful rest of your day.